David Sloan. I'm from the Environmental Advisory Committee. And tonight is the last lecture of our series for this year. And I would like to present Rich Pullman. Rich is from the U.S. National Weather Service in Pontiac and White Lake. He has spoken here in the past. In fact, he was here a year and a half ago, and he correctly predicted the winter of 2015-2016. Rich is from Temperance, Michigan, which is right at the bottom, right near the Ohio border. He received his BS in meteorology from the University of Michigan. He is the chair of the Michigan Severe Weather Awareness Committee, and he is also the Warning Coordination Meteorology Office in White Lake. Rich is going to talk about the impacts of climate change on Michigan, heavy rains, and what is this, how important is this and its significance on Metro Detroit and our area. Mr. Pullman.
Well, thank you. If you have questions along the way, I'll be happy to answer those questions. Yeah, I'm a meteorologist at the National Weather Service office. Under the National Weather Service, we're part of NOAA, the National Oceanic and Atmospheric Administration, and that's part of the Department of Commerce in the federal government. So NOAA does have a lot of climate scientists that are studying this. In the National Weather Service, we really try to hone our forecasts on a 7-day window. So we have a lot of meteorologists in the National Weather Service. So I'm going to rely on a lot of the NOAA climatologists that have studied this to help me with the information. By trade, I forecast in the 7-day window. At the National Weather Service, we'll go as far and as bold as a 90-day forecast, which gets back to that winter forecast that I made a couple of years ago. And so the NOAA climatologists are the ones that are doing this research, that serve on the international committees and really are the basis of this talk. So I got to give them credit where credit is due, and I'm just going to be relaying that scientific information to you to kind of relate it to how it affects Southeast Michigan and Michigan as a whole. So again, if you have any questions, don't hesitate to ask. First, we're going to kind of define climate, look at some of the science, and then look at Michigan specifically. And as I mentioned, when we talk about weather, we're talking about severe weather, we're talking about the floods, the things that we can forecast in that 7-day window. There are some events that kind of bridge between weather and climate, like heat waves and droughts, where you're talking about something that can last for years. And so we're on that edge between a weather event and a climatic event. And so climate certainly gets into the El Nino, and that's what sort of this satellite here is representing, the El Nino, La Nina phase, the overall trends in temperature and moisture that we're seeing, the Dust Bowl era event, the big drought in the 30s. That is also more on the climate side, where you're looking at a decade-long weather event. And so a pretty common way to look at this is like walking a dog, where as we're walking down the street, we're walking pretty straight on our course. We have a course, and that course is how the climate may be changing. Meanwhile, the dog is going all over the place, sniffing that hydrant, that bush, that section of grass. As the dog goes back and forth, those ups and downs or side-to-side movements, that's the fluctuation that we see in weather. But overall, that weather pattern is going in a direction that we're walking. And so that's the climate, while the ups and downs along the way is the weather events that at the National Weather Service we're trying to forecast. So as the cartoon has, the elephant in the room, we talk in terms of climate change. I know global warming is out there, but more scientifically, we're looking at climate change and all the aspects. It's not just the warming of the planet, it's all the aspects of this, the effects of that. And so we prefer the word climate change. 97% of the climatologists around the world, 97% of the papers out there all agree with this diagnosis of the climate change across the world. and that it is more than likely, much more than likely, that it is caused by human action, human activity. And so that is that 97% confident level. And so it's important that you get the information from those scientific pieces, scientific journals, and from the scientists that are trained in climate. And even as a meteorologist, I say this up here as I'm talking to you, the difference between meteorology and climatology, kind of like getting heart surgery from a different type of doctor than a cardiologist. Each doctor has its specialty, and in the world of science, each of us has our specialty. So in meteorology, we have that specialty of that 1 to 7 day forecast, maybe 1 to 3 month forecast, whereas climatologist is going to be looking over the course of the history of the world and what's going to happen in the next 100 years. And so while there is a lot of information out there about climate change, again, important to keep you note of that where that source is coming from. Not to say that there's not a role. Obviously, the news and media has to distribute that information on climatology and let everybody know what's happening. Our politicians have to decide what the policy is going to be. So they are going to be involved. Out the back of my neighborhood, I have a bridge that's been down for 2 years. And without that bridge, I have to make a very dangerous turn, left-hand turn on M59. If the bridge was there, I could get to a traffic light to make my turn. I know where I want the next $500,000 to be spent by federal, state, and local funds and that bridge, and not necessarily for climate change. But then we do have to look at the entire, policy apparatus at state, local, and federal levels to see how we're going to combat different things and how our tax dollars are going to be spent. So politicians are going to be involved in the climate change. We shouldn't be discussing the science as much as the policy. And there's a valid debate on how our tax dollars are spent, no matter where they're spent. All right, so climate's all about this greenhouse effect. There's a natural greenhouse effect. It's obviously what gives life on this planet. We need a way to sort of trap the sun's heat to warm up the surface so that it's a nice average 50 degrees across the planet so that we all can sustain life and live. And so that's a natural effect. The carbon dioxide, the methane that make up the greenhouse gases. The issue that has happened over the last 100, 150 years is that we have added to the amount of carbon dioxide and methane especially to increase this greenhouse effect so that we were able to trap in more energy from the sun, and that's what's caused the global warming more than anything else in the last 100, 150 years. We need some of it. It's just that we've reached a point where we've gone beyond. And so this is the most famous carbon dioxide measurement on the top of the mountain in Hawaii that shows the natural or the very steep rise in carbon dioxide. And that's, of course, just been measured since the 50s. So we have that rise there. And that red line there is the rise that we're seeing from the observatory. So we do have ice cores that that the climatologists are looking at. We'll use whatever information we can to look at the past, whether it's tree rings, ice cores, and try to piece together that piece of the past to know where we've been, what changes happen in the Earth system from solar output, ice ages, and different things like that. And so with some of the ice core samples, we are able to get back to almost 1 million years in our past to get an idea of what's happening. And so we can see that the carbon dioxide levels in those ice cores do vary in time. We go through ebbs and flows, but over the last 400, 500,000 years, we've never been at a level that we're at now. We have jumped the scale, jumped off the chart. And so, again, the climatologists doing their work, looking all the different ice cores can go back about, back a million years there. And so that's where you get these ice core samples in here. And then using some of the sediment, the particles there in the sediment, using some computer models, they're able to go back in time to see what the carbon dioxide was back in these times. And yes, we do know that places like southern Alaska was a lot more tropical during the dinosaur ages. And their carbon dioxide, as they model it and as they can sample it the best that they can, is at a level that's higher than where we're at now, closer to that 1,000 parts per million, whereas we're at the 400. So that star's about where we're at. So, and then these are the future models of where we could be headed, depending on low emissions, moderate emissions, or continue on the same emissions that we have now. So the Earth has been in those stages, billions of years ago, and it's just a question of, what the Earth looked like then, what sort of life-sustaining ability do we have, what sort of crops can grow, and where are those crops going to be grown? America's breadbasket may become Canada's breadbasket, and that's actually a disadvantage to the United States. We're some of the world's biggest producers of food because of our breadbasket area in the Central Plains. Other greenhouse gases are also on the rise. It's not just carbon dioxide, but methane and this nitrous oxide. And in that same time period of the rise of the carbon dioxide, we've seen this rise of temperatures across the globe. And so it's a pronounced, there's no doubt that the temperatures are rising, and it is tied to carbon dioxide. There may be some little bit of debate left over how much is human caused. And that's where we get into some of the modeling, some of the studies that the climatologists are doing. So the black line is the observations over the last 100 years. Then the blue and the green are different computer models. And there is always going to be a range. The computer models are far from perfect. And so there's always going to be a range in those computer models. But you can see that if we had just natural forces only, we're tied pretty close up to about 1940 with the observations. But then the computer models do go off the rails compared to the observation. When you throw in the human factors into the climate computer models, it does tend to, fall within the spectrum of possibilities of those computer models looking at what's already happened. So it does give the climatologists confidence in looking forward. If we can model the past with our climate models, it does give us an idea of what's going to happen over the next 100 or 200 years using those same climate models. So there are 11 indicators of the warming planet, whether it's increasing moisture in the atmosphere, the air temperature, shrinking glaciers, shrinking snow cover, sea ice is shrinking, and all these other things, sea surface temperatures, sea levels rising. And the one up here, the stratosphere, is cooling, which is actually the layer of the atmosphere above where we're all living. The troposphere is where all the weather happens in the lowest 50,000 feet. From 50,000 feet to about 150,000 feet is the stratosphere. And a trait of a warming troposphere is a cooling stratosphere. And that is happening up there.
What does that mean?
What does that mean by having a cooler stratosphere? That cooler stratosphere is, I'm going to try to put this.
Don't be politically correct.
Well, no, I'm not worried about the political correctness. I'm worried about being scientifically correct. Because I don't study the stratosphere as much because all the weather happens in the troposphere. I don't want to say something that's wrong. That's the main thing. But that cooler stratosphere is going to lead to, I guess I don't have a good answer for you on that one, and so I apologize on that.
So I don't know about the implications of it in terms of the consequences, but correct me if I'm wrong. My understanding is that that's a fingerprint that is caused by humans and not by increased solar radiation or something like that, because the greenhouse gases are preventing heat from.
That's right.
getting to
Yeah, that's the science I was looking for, yes. So the greenhouse gases are trapping it in the troposphere, so you don't have the heat radiating through the stratosphere. And so the stratosphere the greenhouse gases are trapping more energy, and so the stratosphere is not getting that energy in it, so it is, as a result, cooling. So when we're talking about climate change, it's not that we're not going to see cold weather and snowstorms ever again. It's just going to be, the cold is going to be less frequent and the heat is going to be more frequent on a global scale. And you'll see that a little bit with the Michigan data. So if this is our average temperature pattern, we have a certain amount of extreme cold days, a certain amount of extreme hot days. You know, average is right in the middle. It basically shifts that plot so that we have less cold weather, more hot weather, and even more extreme record heat. On the precipitation curve, it actually kind of bends the curve to make it flatter so that our light precipitation days don't happen. Well, the new climate creates more of those, so we have more dry. So I guess it kind of just rotates in a way that we have more dry weather and more potential for the heavy rain. And I know the reason for that shift in the precipitation is that in climate change, we've seen most of the warming occur on the poles. So what drives all weather is the fact that it is warmer at the equator and colder at the poles. And so the Earth wants to balance that out, always. It wants to take the warm air north and the cold air south, and that's what generates the storms. It's just about heat transfer. Well, with almost all of the warming happening at the poles, it creates less of a temperature difference between the poles and the equator. And with less of a temperature difference, there's going to be a little less active weather patterns. And so what we have seen in our climate change era is that the weather patterns tend to be a little more stagnant. They don't change as often. And so places that are wet tend to be wetter more often. And you get more of those heavy rain events. And the places that get into a dry pattern are holding on to that dry pattern longer. And so you get more of the dry. So a lot of times I get that question, well, how can climate change bring about both wetter conditions and drier conditions? It's just that the patterns are a lot longer, and so that if you're in a wet pattern, it's wetter, and if you're in a dry pattern, it's drier. And so this graph is just showing how different studies are all pretty much in agreement with this correlation of the temperatures across the globe and how they've changed over the course of the last 130, 140 years. And when you go back in time and try to map based on tree rings and ice and sediments, when we go back, you know, the climate models are get a little bit off, but when we have accurate, modern details, the climate models tend to be snapped right on to what the observations are. So how does this affect, yeah?
I was sort of thinking as you were talking, the business of the rainforests being destroyed or cut down, or, you know, everyone is fighting about how much is there or how much is not there, the development and stuff. Where does that affect the rain, well, the climate, but doesn't that also affect how much rain one way or another?
Well, I think the biggest factor is just how that is affecting the carbon dioxide in the atmosphere by cutting down the trees. You know, whether it affects the rainforest amounts, it could be a little bit, because certainly those tropical plants are giving off a lot of moisture as well. So maybe the what I call the surface or the boundary layer moisture profile in the tropical rainforest wouldn't be as high. That's a potential, but I don't know if anyone's done any studies on that specifically. You can see where that would be a question, a hypothesis that somebody might come up with to study, but I'm not aware of anything to say definitively. So this is looking at recent trends, really over the last 110 years. You can see that most of the United States is quite a bit warmer when compared to 1900 to 1960. Over the last 20 years, we've had much warmer conditions. Warming is strongest during the winter, especially for the northern tiers of the United States. And so when we look at Michigan, since most of our warming's over the winter, this isn't actually a big surprise. But these are the number of days where our maximum temperature is above 90 degrees. And there's really not a huge trend there. We had a huge trend of above 90 degrees there during the Dust Bowl era. That actually was human caused. The over farming, the overuse of the soil, making it barren out there to our west. And that is the way to warm up Detroit, is to have warm, dry winds blow from the southwest into us. And so this is actually directly related to human activity on the Dust Bowl scale. It was so dry out there, there was no moisture, no plants, and that heat, when it blew in from the southwest, had no barrier between Detroit and southwest Kansas. And so that's how we get our hot days here in Michigan. And so overall, we're not seeing an increased number of 90-degree days in this temperature trend. We are seeing more warm nights. I mean, overall, there's an upward tick in those warmer nights. And so our greatest change in our average temperatures from the turn of the century at 1900 to our current is that our overnight low temperatures have warmed about 3 degrees on average. And so that's where we're seeing the bulk of that. And it doesn't matter whether it's an urban area with the heat island or a more rural area. We're seeing warmer nights as a whole. And there's also a trend of less cold nights. We did have a very cold period there in the 70s. So not surprising that's in there, but that is just one period. If we look at the overall trend in our database, there is a trend of less cold nights, very cold nights, in the state of Michigan. So climate change is a lot more than just temperatures. We're going to talk about rainfall in specific, so that's a little bit on the rainfall. This is a map showing the potential of rising sea levels and how this is going to affect this region, which I think is the Chesapeake Bay. This is a map showing you or a graph showing you the Arctic sea ice and how that is decreasing over the course of time. And then last is the billion-dollar disasters, and this is inflation adjusted, so this is using constant dollars, and that our billion-dollar disasters are increasing. There's another piece in there that's not included in the graph, or should be included in the graph, is that there's more targets of opportunity. Our population's up to 330 million, so there's more buildings. So if you got more buildings to hit, and you have a tornado move through, or you have a hurricane, you're going to have more billion-dollar disasters because you just have more things in the way. And so that hasn't been teased out of that data set. So I don't know how much I like that particular graph in this presentation. So recent precipitation trends show a lot more wet conditions in the north half of the United States. Deserts tend to be drying out more. South is a little bit drier as well, when compared to the first 60 years of the last century compared to the last 20 years. So we've seen that definite increase in precipitation in the northern tier of the United States. And this is showing up very clearly that we've got much more precipitation in the state of Michigan in the last half of the data set compared to the first half. So we're definitely increasing our precipitation. Snow melt is happening earlier. So we tend to see the snow cover 20 to 30 days ending earlier. Of course, a couple of years ago, it was a cold and snowy winter, so it hung around a little bit longer. There are going to be those years that harken back to some of the older days, but on average, we get a little bit more of that. In the Mountain West, they've been seeing, in general, more snow, less snowpack across the Mountain West. Interesting that there's a little bit of an increase over the Sierras. And this data was in 2014, right at the start of their last drought. And then the sea ice is also melting across the Arctic. Again, with most of the warming in the poles, we're seeing that Arctic sea ice decrease in time. And so each year tends to be setting a new record. And that didn't change in the last 2 years either. So despite the Michigan data that showed that there wasn't as many 90-degree days as in the past during the Dust Bowl era, across the United States, we're seeing more record highs than record lows. And so this is that trend from 1910, really the last 100 years. You can see how the record highs are increasing versus the record lows. We hardly see any of these much below normal temperatures compared to the much above temperatures. So on the extremes, we're seeing more extreme heat than we are extreme cold, which makes sense with that graph shift that we saw. There's still going to be cold days. We're just not going to have that record cold, the extreme cold, compared to the number of extreme hot time periods across North America. This one's talking about the number of heavy rain days. So we're not looking at the yearly average of temperature of precipitation, but we're actually looking at the number of days we get very heavy rain, the rain that leads to flooding, especially in an urban area like Detroit. And so across the Great Lakes region, we're seeing an increase of 37% for the heavy rain pattern that's increasing. And so this is the Michigan graph, and we got the Michigan graph here for the number of events, weather events that produce 2 inches of rain or more. And there is an uptick in that. And I'll show you this other graph that shows you that if we look at the days, the 1% of days where we get the heaviest rain. So we can look at that as, 4 days. The 4 days a year that we get the heaviest rain in Michigan. Average of those 4 days is increasing by 20%. It's a pretty solid, 10 to 20% increase in that. I don't have the data here, but I have seen the data that if you look at return frequencies, so you hear about a 100-year rainfall event. What that means is that you have a 1% chance of that rain event happening in your location that year. So you can have a 100-year event 2 years in a row. It's just if you were to average that over time, you would only see that rainfall event once every 100 years. So prior to, in the first 50 years, from 1900 to 1950, that heavy rainfall event, that 1% chance of getting a heavy rainfall event was at about 4 inches for Metro Detroit. That 1 in a 100-year event, that 1% chance of having that heavy rainfall event is now up to about 5 inches. So we've seen almost a full inch increase in our once every 100-year event. And that has huge implications if you're designing infrastructure in a metro area where you have stormwater plans and how you deal with that, which is kind of leading into the last part of what I'll talk about. Now, in the Great Lakes, this isn't all bad. We are increasing our growing season on average by 9 days a year. So that's actually a plus for the Great Lakes region. And we have the natural barrier of the Great Lakes to help keep our plants from freezing too early or too late in the season. And so that's why we have such a huge agricultural business surrounded by the Great Lakes. And I suspect that's actually could only increase in time. So we actually have the opportunity to have a bigger agricultural footprint for the United States here in the state of Michigan. So that's actually a benefit. It certainly helps us out. Now, in the south, it may just be getting too warm to grow anything. You may have some issues with that, and it's also drying out in the south. And so the drier is a problem when you're trying to grow anything as well. So this is the projected temperature change. If we curb emissions, we're still going to warm. There is a lag effect to all the carbon dioxide that we're put into the atmosphere. And so as we look ahead in the future, if we stopped and curbed our emissions at this point, we're still going to have this warming because there is a lag result of all that carbon dioxide. No emission change, we're going to be at the top end of the scale. And so this is a forecast for 2070 to 2100. And so you can see the entire country does have warming. Most of the warmth is in the north. And that's what I mentioned. In the poles is where we see the warming happening more dramatically. This is specifically for Michigan. This is sort of the model historic version, and you can see how observations kind of fall in that window. And so if we take those same climate models that did pretty well with the past, and we take them out into the future, with our lower emission forecasts, actually it's a pretty wide range there, from just warming another 2 degrees up to another 8 to 10 degrees. With a higher emission forecast, we start out at that 8 degrees, and we can go up to 16 degrees as an average temperature over the course of the year. Both highs and lows, averaging them all together, you can see where we're at. So even if we curb today, we're still going to see, at the lowest end, another 2 degrees of warming on average. The projected precipitation change, you can see it's going to be wetter up north, and Michigan's right in there. So the winter and spring, the cool seasons tend to be the area where we're going to see the more precipitation, actually drying out in the summer. So it looks like that's not good for the crops. Remember I said our breadbasket out there in the plain states is going to be drier and hotter in the summer. It's going to make it much more difficult to grow anything. And so those are some of the ramifications that we need to pay attention to as we go through climate change in the past. So just looking at the science, it's real. Experts agree. It's more bad than good. And it's still possible for us to come together and solve this problem. Michigan's key messages is that our temperatures are going to continue to go up. Eventually, as the temperatures go up, that extreme heat, even though it hasn't shown itself yet, that extreme heat could show itself, and we do flip the switch and get more of those extreme heat days. And urban centers like Detroit could become a potential issue. Winter and spring precipitation are expected to continue to increase, which is just going to increase our risk of springtime flooding, whether it's from snow melt and rain or just rain on frozen ground or ground that won't absorb the rainfall as much. I didn't mention a lot about the Great Lakes because the research is still out on that. The speculation is that this precipitation pattern is going to actually lead to more fluctuations in the Great Lakes, more rapid changes. Right now, we see our Great Lakes water levels change about every 20 years. In the 80s, it was really high. Around 2000, it got low, and we're seeing a rebound of our Great Lakes. And if you go back in the past, Lake Michigan and Lake Huron data, Lake Michigan and Lake Huron data goes back about 150 years. And so we do have some record of those lake levels, and it's about a 20-year cycle. Speculation is that cycle may short with climate change. And right now that's all it is our scientists are speculating on that. It turns out what we have seen over the last 20 years, because our lakes are rebounding now, is the evaporation is not as big of an issue as the amount of precipitation that falls. Because our Great Lakes have been rebounding very nicely. Our levels are really nice, and that all has to do with precipitation that falls in the Great Lakes Basin, especially the winter and springtime precipitation. And it turns out evaporation is certainly a factor lower than precipitation amount. I know 20 years ago, a lot of the research was talking about if we don't have ice cover on the lakes, you're going to have more evaporation. Our lakes are going to go down. In 2000, they were really low, at all-time record lows, and people were concerned about the evaporation. It turns out precipitation is the most important factor. It's at least twice as important as evaporation. And so we've been very wet for the last 5 or 6 years, and our lakes have shown that. We've rebounded nicely.
Well, with the water levels rising around the world, the Atlantic, all the oceans rising and the ice melting is bringing up the water levels in the ocean, right?
Yep.
Okay, well, wouldn't the St. Lawrence Seaway that flows into the Great Lakes, wouldn't that affect the Great Lakes water level?
Maybe at the mouth of the St. Lawrence Seaway, but our lakes are at 500 feet above sea level.
Oh.
So, yeah, they're significantly above that, so it's not going to affect them.
Do you have any predictions about the winter?
Next winter? Well, my prediction last winter was that it was going to be colder and snowier than the previous one, which was like all-time record warm and not much snow. And we just barely did that this year. So since we had the 8th warmest winter on record and we had a below average snowfall, I will say that it'll probably be colder and snowier than last year. So we'll wait to see how the El Nino and La Nina phases happen. In the northeast quarter of the United States, our climate forcing features are really only predictive on about a month-by-month scale. El Nino and La Nina affects the southern half of the United States a lot. It's the number one factor in how their pattern sets up. And so if you know what the El Nino and La Nina forecast is, which we have a pretty good handle on forecasting that a year or two in advance, you can then forecast south of the Mason-Dixon line pretty good. Up here in the Great Lakes and for the big cities of Philly, New York, and Boston, it's tough to forecast much more than a month in advance because La Nina and El Nino patterns don't have as big of an effect.
So how about this summer then?
Now, summertime climate forecasting is difficult in the fact that in wintertime, our average temperatures in winter have ranged from 12 degrees Fahrenheit to 40 degrees Fahrenheit. So we have a huge range of possibilities. Our records in the summer go from 67 to 77. So it's only 10-degree average temperature swing in the summer. So it's a lot harder to hit that window to say colder or warmer than normal. Right now, it looks like the pattern of wetter and warmer than normal will continue into the summer. And so that's the way we would be leaning. A slightly warmer, a slightly better than average chance of warmer and wetter conditions continuing, which is really kind of what I just talked about. That's what we would expect to continue to see. All right, so I want to talk specifically about one issue that we see here in Metro Detroit with this urban hydrology. What happens here in our urban center is something we've been seeing. Of course, we all know about the historic flood 3 years ago this summer. And that loop's not going to work. Am I going to have to click on it? Well, yeah, we're going to click on that. Should loop. Well, We'll pretend you see the radar with all the heavy rain coming in Detroit. I'm not sure why that didn't leak. It will look like it wanted to. But we remember what happened there. We had a widespread 4 to 6 inches of rain over Wayne County, southeast Oakland County, and southern Macomb County. We also had some flooding in Flint and Saginaw, Bay City, obviously not as dramatic in Detroit, because most of that rain fell in about a 3-hour time window. So we issued flood watches and flood advisories, then flood warnings, widespread historic flooding, over $1.5 billion worth of damage. It was the worst natural disaster for the state of Michigan as far as cost. Even adjusting it for inflation, it was the worst. Here we got our radar loop working. 2 years ago, that should be 31st, we did have some flooding here where we had flood watches, some freeway closures, had some dry conditions to begin with, so this 1 to 3 inches of rain in a short time window didn't quite cause as much flooding as some of the other ones that I have here, like July of last year. We had July 7th through 8th during the overnight hours. We had all this rain over Metro Detroit, several rounds of thunderstorms. Rainfall was about 2 inches of rain, happened right at morning rush hour. So we had a lot of freeway closures again, sewers that were overflowing. This was a slightly different event at the end of July of last year. We had a roof collapse. It was a flat roof, and the water just piled up on the flat roof, and the roof collapsed in Ypsilanti. And so one of the hazards of not having a peak roof where the water can run off. And so we had locally 5 inches of rain. This was more from slow-moving storms that would sit over an area for one time period over the course of those 2 days. So a little bit more sporadic in the flooding because there were more slow-moving storms sitting over one location. And that location would flood. It wouldn't be widespread. This was actually kind of more of a winter storm in its setup, where we had a widespread swath of heavy rain that came in during the overnight hours. And they produced up to 10 inches in South Bend. Luckily, we didn't get that rainfall. It was more 2 to 3 inches of rain over southeast Michigan. Again, Metro Detroit, highways and roads were closed because of the flooding. And so there you can see all the heavy rain that was hitting. And that's at 2, 3, 4 o'clock at night. And then the morning rush hour was a mess. This is actually a thunderstorm event where we had some help from Lake Erie. We had moisture coming off of Lake Erie. You can see this line of storms just lining up over Wayne County here. And so it starts at the evening hours, kind of wanes a little bit overnight, then the next batch gets going. And so we have another line of thunderstorms that hit. And then finally we get another batch right in there, right at, and that's where most of the heavy rain fell, right there at morning rush hour. Continue to see that heavy rain coming off of Lake Erie. So we had up to 5 inches of rainfall in the city of Detroit, and we had many, many roads closed. So I just went through 5 or 6 events where we had a variety of events, but the impacts were similar. Basements were flooded, widespread highways were flooded. Some differences in whether it was localized versus widespread. And even at the Weather Service, we're trying to get a handle on this urban flooding that we're seeing a marked increase in. Whether we issue a flood advisory, just a generic flood warning, or flash flood warnings. And I think through all these events, you've seen us issue all of them. We're just trying to, grapple with what is the right message to get out to people. And we're trying to get our hands around that as well. Obviously, there are some concerns with our infrastructure. Our infrastructure is 100+ years old. It was designed to handle a 100-year rain event being a 4-inch rain as opposed to a 5-inch rain now. So these heavy rain events are coming in more quickly. Our freeway systems are mostly built under the ground, and so that's not necessarily the best way. That's where water's going to collect. And so there's a whole host of issues that we have to think about and how our infrastructure can handle this and how we go about replacing that and being able to handle these heavy rain events, especially these quick, intense rain events, which we have seen through my presentation are increasing in size and in scope and frequency. And so I don't think this problem that we've seen over the last 3 to 5 years is going to be going away anytime soon. I think at our office, we're getting more quick on the trigger with a flood warning or a flash flood warning when we see those heavy rain events. Because if a highway's flooded, a road's flooded, that becomes a life-threatening situation. We want to get that information out. So again, I want to thank you for coming out this evening, listening to me talk a little bit about climate, and I'll be happy to take any questions that you have. Yeah?
What is your equivalent in the Florida state of the folks? Because they're dealing with the sea levels and all these other things. It's all a very low state. And so even on a state-by-state basis, the same presentation must have tremendously different results.
Oh, on a state-by-state basis? Yeah. Yeah, the resources that we have at NOAA, they do outline the differences from state to state. And so, yeah, the coastal areas are going to be most concerned about the sea level rises. You know, you live in New York City, you live in Florida where everybody lives on the coast. It is a completely different presentation than what I'm giving here. I know I didn't have this piece of information in there, but some of the NOAA scientists have worked in, you know, one of the things that could be an issue in 100 years is our sugar maple trees may struggle to survive. We may have a climate that's more similar to Arkansas. They don't have sugar maples down in Arkansas for a reason. And so we may see a change in what animals live around here and what trees and plants are able to grow. And so that's another aspect that I didn't touch on that's going to be different from state to state to state. So yeah, it is completely different down there. And I wouldn't begin to know what all the ramifications are of climate change for individual states. Yeah.
There was an article in the news just about 2 weeks ago talking about tree migration and how they can see that the pattern of trees is moving, and the seedlings are moving differently from different areas because of the changes to the climate.
Yeah, and that's certainly something for U.S. Forestry and Department of Interior. That's something that they're studying even more than NOAA is. Obviously, they're working together. NOAA has the climatologists that have the climate piece of that study, but then you're dealing with, you know, agricultural and botanist experts that take that climate piece and tie it to what they're seeing with the plants. And so, since I can just touch on the weather and climate aspect, I'm not going to venture into all the tree aspect and what's going to be happening, other than the fact that, yeah, we know that that is what they have found, and just that article that you mentioned highlights that. Yes?
I'm just curious if you've had the chance to talk with people in like farm bureau groups or in rural areas and how they respond to this information.
I haven't had the chance. You know, as far as speaking with people in a more agricultural community, Michigan State is very active in agriculture community. That's where the state climatologist is. So there's a climatologist office in Michigan State. And so a lot of the data I got from him and his office. So there's a group of people there that are closely tied to the agricultural community in the state of Michigan. So I'm speculating, but I'm sure he has, and his group has talked to many people in those rural communities. Yeah.
Are there, then, sort of related, are there discussions with urban areas, because the severity may seem to affect us more than
Yeah, the question with the urban areas and how to manage that, I do work with the Detroit Climate Action Group. And so that is a group that is Detroiters for Environmental Justice, U of M School of Public Health, along with their climatology group, Michigan State, and then the State Department of Community Health. And so there's a lot of partner groups that work together to figure out messaging, figure out even going census tract by census tract to see what might be the most susceptible areas to extreme heat and what is the urban design for our changing planet. And so yeah, there is a group that's working on it, and I serve on that group as the local weather service expert, if you will.
I wonder how much the actual governmental units are reaching out to say, we need to understand this, because everyone's doing a good job.
Yeah, and I don't know. I know each city is a little bit different in their activity as far as green spaces. So I don't know. I know certainly with the city of Detroit with more vacant buildings, those are being turned into green spaces, and that actually obviously helps. It helps reduce the urban heat island footprint. Yeah.
So when we hear your warnings throughout the day getting worse and worse, is it about all we can do is just kind of pay attention when you're driving? Because the streets might be flooded, because you're not gonna do anything about the basements. I mean, if that happens, it happens, but, I mean, is there something that we should pay attention, when those warnings come out?
Yeah, we're issuing our warnings for the protection of life and property. And so when we issue our flood warnings or flash flood warnings, we do not want you to drive in a flooded area. We have a little rule that we teach our school-age kids. When you see a flooded area, turn around, don't drown. The best case scenario is your car may get caught in that flood and it stalls out, and you got to pay for the tow truck and then explain to your insurance company what you did. Worst case scenarios, even here in Metro Detroit, while the water may be standing, it can easily get over the top of the car, panic situation. It does become a life-threatening situation. And we have enough streams and creeks around here that can flow out of their banks. Only takes 1 to 2 feet of moving water to have a car or SUV or pickup truck float down the stream. And obviously our cars are not designed to be boats, so we want to keep them on the dry pavement. And then for the protection of property, I think everybody knows if their home is susceptible to basement flooding or susceptible to the Clinton River overflowing its banks on it. And so we issue those warnings to try to give people as much heads up as possible that they're going to want to double check their basement, double check their whatever provisions they have before the Rouge River or the Clinton River goes out of its banks and threatens their home. But yeah, in Metro Detroit, it's mostly going to be for the drivers to make sure that they don't go into any flooded area. All right, I do have some brochures in the back that you're welcome to pick up if you didn't get a chance. Just a couple of quick ones on weather safety and our climate services in Southeast Michigan. And again, I do want to thank you for coming out and listening to me talk a little bit about climate and how it's going to affect Detroit and Michigan. Thank you.
We want to thank Rich for coming and giving us his words of advice. This is the last of our 7 series of lectures. We hope to have another series of lectures starting this fall. And if anybody has any suggestions, please contact us. This is the Environment Advisory Committee, and we're trying to come up with programs and ideas to help the residents figure out what to do with the water on their property, whether it is to infiltrate into the ground, or what to be aware of. And I would say one suggestion, if there's a heavy rain projected, to stay off the freeway.